Okay, so today what I want to do is kind of quickly go through some main Python concepts and the idea of objects, since Python is an object-oriented language. I'm going to kind of quickly go through a bunch of slides. I urge you to work through these slides more slowly yourself and make sure you understand what's on them. But I just wanted to point out some of the things that are kind of sticking points if you're not familiar with Python to start with. We could obviously spend all quarter doing a Python programming course, but basically, I want to get you started doing some things because we will be using Python for plotting as we go along, and it's very useful for a lot of things. And so I'll talk a little bit about some data types and modules, and then switch to a demo and try to get to looking at the IPython notebook today as well. So how many people are familiar with object-oriented languages? About half the people, at least. So if you're not familiar with it, it's a little different from procedural languages, so I wanted to kind of point out some of the main features of something like Python. There are a lot of advantages of Python. It's a nice interactive language, as we've seen. That it's a lot like MATLAB, and as we'll see later today for plotting, a lot of the commands are very similar. You can try out ideas very quickly, and there's a lot of Python modules that you can find on the web that are available for more specialized work in various different directions. It's also open source, and so you can run it on pretty much any platform. And as we'll see later, you can combine it pretty easily with languages like Fortran or C to do more complicated things. And it's often used as kind of a higher level gluing language, even if the lower level code is in other languages. So the reason we don't usually use Python for everything is that it has the disadvantage that it can be fairly slow to do certain things. And we'll talk more about this probably next week. But Python is an interpreted language rather than a compiled language normally, although there's some work going on now on sort of just-in-time compiling for Python, which maybe we'll talk about later in the quarter. But the basic Python language is interpreted, which means that rather than compiling your entire script to machine language before running it, every command is sort of individually interpreted. And that slows things down, especially if you do something like write a loop where you're looping over elements of a long array. It can be orders of magnitude slower than doing the same thing in Fortran or C, for example. But there are ways to get around that. You can use things like NumPy, which we'll talk a lot about, which is numerical Python, which gives you arrays that you can work with the same way as in MATLAB, if you're familiar with that. If you do things in a vectorized fashion using arrays, it's typically much faster because under the hood it's then calling compiled C code instead of actually interpreting each command in Python. And there's ways that you can couple it with Fortran using things like F2Py, which I'll talk a little bit more about later, or with C using Cython to kind of make it much easier to make parts of your program run much faster in one of these languages.